Now we gain some experience with function notation as it applies to mappings, sets of ordered pairs, and graphs. Not as it applies to equations. That's a given when you're dealing with equations, but mappings, sets of ordered pairs, and graphs. Now the good news is, let's recall function notation here. F of x equals y. And so what you have is the name of your function, your input here, and this is your output, which is equal to all of f of x. So f of x is also the output. Okay? The easiest thing to remember though is that your input is the thing inside parentheses. Okay? So just keep that in mind. So now let's start with a mapping. I'll draw a mapping that represents a function and we'll just interpret it with some function notation. So here we have a mapping to represent the function g, and the first question I want to look at is maybe determine g of -6. Okay, so what is that asking us for? G of -6 means, okay, the input to g is -6. G of -6 means y. So this is like saying determine y. So the input to g, that's 2, g is -6. What's the output? Okay, so it's pretty simple. You come over here, we know because there are arrows that -6 is my input and the output for -6 is 8. So I can say g of -6 equals 8. When I input -6 to g, I get 8. That's what that's saying. Okay, now let's try something similar. Determine all x values for which g of x equals 8. So what is that asking us for? Well, they're asking us determine the x values. They're saying, okay, what are the inputs? And what do they tell us? They tell us that g of x is 8. So in other words, they tell us that y, g of x is y, y equals 8. So what are the inputs if the output is 8? So here's our output of 8. The inputs for that output go back to -2 and -6. So if g of x equals 8, then x equals, let's write some words here. If g of x equals 8, then x equals -2 or -6. And the key here is that the question asks for x values, so you better give x values. Not ordered pairs or anything else, just what does x equal, okay? So that's how you use function notation with a mapping. Now let's look at a set of ordered pairs. Okay, so now I have a function that's written as a set of ordered pairs, right? And so the first question that I want to answer here is determine R of 3. So I know that my input to R is 3, and R of 3 means what's the output, so determine the output. So I go up here, I locate where an input is 3. Well, here there's an input of 3 and nowhere else. If anywhere else had an input of 3, this wouldn't be a function. So my input is 3, and whenever 3 is my input, my y value, or my output, is 1. So when 3 is the input to R, that equals an output of 1. So R of 3 equals 1. Let's do another one. Determine R of 5. R of 5, I scan through and I find an input of 5, which is here, and the output is -4. So R of 5 equals -4. Okay, let's do one more. Determine the x values for which R of x equals 5. So now I'm looking for inputs or x values, and I know that y, or the output, is 5. So now when I scan this, I look for outputs of 5. And I have an output of 5 here, and the only input that gives me an output of 5 is 2. So r of x equals 5 only if x equals 2. So that's the only x value in that case. Okay, so that's a set of ordered pairs and how to interpret function notation with it. So now I have a graph of a function f, and I want to determine f of 2. So I know my input, or x, equals 2, and f of 2 means what's y. So I need to know my output. So I scan my x values, which now are on the x-axis. X is 2 right here, which leads me to this point that has an output of 3. So I can come back over here and say, well, f of 2 equals 3. My output is 3 when my input is 2 to the function f. Okay, let's do another one. Determine f of negative 20. So now I know that my input, or x value, is negative 20, and I want to find my y value, or my output. So I come over here and I scan. Negative 20 is way over here. I can't even see it, but I do know that the graph stops at negative 11 and doesn't go any further. So what is the output if the input is negative 20? Well, there is no output. So you could write no output if you want. You could say undefined is maybe a more common response. Negative 20 is not in the domain of this function, right? It doesn't have an output. Okay, let's do another one. Determine the x values for which f of x equals negative 1. So now what I know is I'm looking for x, and I know that y equals negative 1. So now I'm scanning my y-axis. Y is negative 1 right here, and I can see that I hit 2 points when y is negative 1. The question is, what are those x values? Well, the x values are negative 2 and negative 6. So f of x equals negative 1 if x equals negative 2 or x equals negative 6. And that's how we apply function notation to a graph, to a set of ordered pairs, and to a mapping. Same thing every time. Number in the parentheses is your input, and g of, f of, whatever is always your output, or your y.